So this wee unit is all to do with forces, and to start off with forces you need to discuss the difference between weight and mass. And ordinarily if you go to the shops you'll find fruit and vegetables and they're measured in grams and kilograms. But in physics this is slightly wrong because we're so used to saying that we weigh something. We're really saying what is the mass of something. So the mass is the amount of material that you would find in any object, and that is measured in kilograms or in grams, and the units that we would use there are kg or g for grams. So the mass tells you how many particles that you have, not what they weigh. So it's the material, it's the amount of matter that makes up. So particles can be as small as atoms, even ions, and then larger things like molecules, and other molecules would make up the whole object. Now, weight is slightly different. So weight is the force, or takes into effect the force of gravity. And that is pulling on the object. So it doesn't matter if you're on Earth or Mars, each object has a particular force of gravity. So weight is a force, and it is measured in newtons. So that will be our units that we'll be using when we're measuring force. So the unit of force is newtons, and the symbol is a capital N. Weight, therefore, for the formula is mass times the force of gravity. Just highlight that there because that's one of your formulas. So on Earth, the force of gravity is 10 meters per second squared. Force is an expression of acceleration or movement, so we use the units of speed, which is meters per second squared. So we'll take the example of 1 kilograms of tomatoes on Earth. So 1 kilograms of tomato would weigh 10 newtons. And we work that out because we have one kilogram times 10, which is the force of gravity, and we get 10 newtons. If you take this same 1 kilogram of tomatoes onto the moon, you would still have the same mass because you still have the same number of tomatoes, but they would weigh less, and that's the key thing because the moon has less gravity than that of Earth. The gravity on the moon is 1.6 meters per second squared compared to that on Earth. Now, if you take a look at the wee caption here, if you have an astronaut and he has a mass of 120 kilograms, on Earth, his total weight would be 120 kilograms multiplied by the force of gravity, which is 10 on Earth, and his weight then is 1200 newtons. If that same astronaut was to travel to the moon, his mass is still the same. He hasn't lost any particles on his journey up to the moon, but his weight is different. If we multiply 120 kilograms, his mass, times 1.6, which is the gravity on the moon, you will get 200 newtons of his weight. So that's why people appear to be floating on the moon compared to that on the Earth, because the gravity is much less. Now, to put that in context, people who sell tomatoes are not normally troubled by the differences between mass and weight, just like us. They are priced in kilograms, not newtons, and since overall they do not try to sell tomatoes on different planets, we can just assume that weight and mass is the same. If we just have a wee look here then at our forces. So a force needs to be applied for an object to cause movement. And basically a force is a push or a pull. A force applied on an object can cause a number of things to happen. So first of all, it can actually make that force can make the object change shape. And you see that if you kick a ball, your foot hitting the ball will cause a dent to the ball very slightly. It'll come back out again with the air and move on. You might have seen it with slow-mo videos of a water balloon crashing to the ground and splashing. You'll see that it expands and moves. So it'll make it change shape. It can also make it change direction. If you kick a ball, you can kick it up, down, to the side or whatever, and you can apply a speed which will make that object change its speed. So other words that we would use for force, obviously we know the one which is weight. You will see that force can be explained as a tension, and thrust. And thrust, you'd see with airplanes, they need to overcome the force of gravity to move up, and they have up thrust. Force is measured in newtons, as we've already said, and we use the capital N for the units. And force is measured using a Newton meter. So something that is a meter measures something. Sometimes you'll see it used as a force meter, which is the same thing. And if we were in class, we'd have a wee practical now using these force meters. On the next page, you'll see definitions of a type of force. If you can copy those into your workbooks, and then we'll move on to the next page, which is given different examples of names and where you'd see that force in motion.